Ever tried setting the perfect price for a product, only to watch market trends flip overnight? It's like trying to hit a moving target with a slingshot, super tricky. That's where Bandit problems come in. Mathematical tools for making smart choices when you don't have all the answers. But what happens when the rules of the game keep changing? That's the wild world of non-stationary Lipschitz bandits, and today, we're unpacking how researchers are tackling this chaos. Let's start simple. Imagine you're a gambler at a casino, faced with multiple slot machines. Each has a hidden payout rate, and your goal is to maximize your wins. You've got to balance exploring new machines to find the best ones, and exploiting the ones that have been paying off. Classic bandit problem. But here's the twist. In this research, the machines aren't just a few slots, they're infinite options, like every possible price between $0 and $100. And the payouts? They don't stay the same. 1 minute a $50 price tag is a goldmine, the next it's a disaster. So how do you adapt? The key lies in Lipschitz continuity, a fancy term for smoothness. Think of it like a hill. If you climb a little, the slope doesn't suddenly drop off a cliff. In this case, the reward function, how much money you make at each price, can't change too rapidly. If a $50 price works, nearby prices like $49 or $51 probably do too. This smoothness is a lifeline. It lets algorithms guess smartly instead of guessing blindly. But here's the real challenge. The hill itself can shift. Maybe a new competitor enters the market, or a viral trend makes buyers price sensitive. The reward function isn't static, it's non-stationary. So how do you track the best price when the entire landscape is melting? Enter the researcher's clever solution, detecting significant shifts. Instead of reacting to every tiny fluctuation like a passing breeze, the algorithm focuses on meaningful changes, like a sudden spike in demand or a crash in popularity. It's like tuning out background noise to hear the siren call of a real opportunity. Here's how they do it. They use hierarchical discretization, which is just a fancy way of saying zoom in where it matters. Imagine dividing the price range into layers. First, broad chunks like $0.50 and $50.100. Then if a chunk starts looking promising, they zoom in further, checking $25.35, then $30.35, and so on. It's like exploring a map. Start with a wide view, then peel back the layers to find the best path. The result? An algorithm that adapts on the fly, without needing to know how often the market will change. The math behind it. It's a beast, but the takeaway is simple. This approach minimizes regret, the loss from not choosing the best option. Compared to older methods, it's way more efficient, especially in unpredictable environments. Why does this matter? Think of dynamic pricing for online stores, personalized recommendations, or even self-driving cars navigating unpredictable traffic. These systems need to adapt in real time, and this research is paving the way. It's not just about solving a puzzle. It's about building smarter systems for a world where change is the only constant. So next time you see a product price shift or a recommendation change, remember, behind the scenes, algorithms are working overtime to keep up. And thanks to breakthroughs like non-stationary Lipschitz bandits, they're getting better every day.